Okay, we've done auto grouping, we've done feature groups. Now we're going to do the alignment file. And this is the last of the input files that you can use in Metacats. Now you can generate this alignment file yourself, or it could be something that you created in BV-BRC. And there are certain services like the MSA service and gene tree services that generate alignments. And I can see the alignments I have that just clicking on this down arrow, and it'll show me alignments that I have generated. But let's say you want to upload one. So you click on the folder, and this will open a pop-up window, and I have to figure out where I want to put it. So I'll put it in here, and maybe I'll put it in Metacats. And then I'll click on the upload icon, and it's looking for something that ends in .fa, .fasta, or .faa. Now up here it says align DNA FASTA. It can be amino acids too. If I wanted to, I could choose that. It doesn't matter. Both of these are going to work just fine. So I click select file, and this opens up a dialog box with my computer. And because it's specified for an FA or a FASTA or an FAA file, it's only going to show those files that have that ending. And here's the one I want. So I'll open that and I'll start the upload. And that's the alignment file. And if I looked on the uploads here, it would tell me that it's 100%. Now I'll need a group file. And this, oh, how have I wrestled with this today? Let me give you some hints. Have generally one condition that you're comparing it to. You have to create a TSV file. I've been doing it in Excel, and I save it as a .tsv file. And the first column is the unique gene identifiers. They're those files that end in PEG. I'll show you this in a second. And the second is the metadata that you want associated with that. So I uploaded one here, and I'll show you what it looks like. So this is a TSV file. After you upload it, make sure that you look at it to see that it's in the right format. So I click the view icon here, and here's what it should look like. 2 columns, one with the identifiers, one with the metadata. And this is just to give you an example. There's no great things I can say about this particular collection of genes. This is just to give you an example. So I'm going to go back to there, and it should show me that file. Yes, here. Okay, so I've got the alignment file. I've got the group file that I created myself. When you bring in the alignment file, you will need this to go with it. Now I need the folder, so I'll call it Metacats, and I will give it a name here, and I'll say alignment, and that looks good. So the button is blue, so I'll submit it. And we have to wait until this green box changes to show us that that job has been submitted. Although these jobs run fast, luckily enough, I pre-run the job. So I can go to my jobs page by clicking here at the lower right and click on the job I want to view and click on the view icon. And notice that this has some different format than we saw previously. We don't have the output file. We don't have the math log. It just has the chi-square table and the MC table. So we want to look at the chi-square table and view that. And here are the 2 headings, resistant or susceptible, and it's looking at the significant amino acids between them at the different locations. So we had 339, which wasn't there, but 371 is. That's one of them. And the resistance all had a T, and the susceptible all had an I. Then 389 was another one. Oh, look at this. The resistant all had the L, and the susceptible all had the 3. Then we had 400, which isn't here, so it wasn't significant at all. It was 514 and 546. 514 isn't listed, so there were no significant differences. But here, the resistant had the valine, the susceptible had the leucine, and then finally we had 605, and resistant had T, and susceptible had N. So actually, this really distinguished between these two groups. So this was good. But remember, you can use your own alignment file, but you have to give it the metadata. I had to give it the susceptible or resistant, and then I was able to run it. So I don't know. I think that's pretty cool. Give it a try. And in the last video, we'll look at where these mutations are on a structure, a little bit different than the structures I've done before. So I hope you'll join me there. Thanks a lot. Bye.